Okay, so example number 2 on page 5. If you combine 28.3 grams of potassium iodide with an excess of hydrochloric acid, how many molecules or particles of potassium chloride will you get after the reaction is complete? Again, putting everything together. Here we go. Okay, so you're combining 28.3 grams of potassium iodide. So that's your given, okay? So I underlined it, said it was given. Excess of hydrochloric acid. That means you have as much hydrochloric acid as you could possibly want. How many molecules or particles of potassium chloride will you get? So potassium chloride is what we need. Now, hints. Starting with potassium iodide, we're adding hydrochloric acid. One of our products is potassium chloride. It has to be because that's what we need. So let's go and balance write and balance our reaction. The very first thing you got to write is potassium iodide. You should know that iodine is -1 and potassium is +1, so when they go together, it's just Ki. Hydrochloric acid. You should know that that's HCl. Okay? All right. That looks like a double replacement reaction to me. What do you think, Ab?
Yeah.
Okay. So everybody's going to switch partners. So K is going to go with Cl and H is going to go with I. So you're going to end up with KCl plus hydroiodic acid, or high, which, by the way, is my favorite acid because it says hi to you. Now, these are all balanced. Hydrogen is +1, or yeah, here, and iodine is -1. Potassium is +1, chlorine is -1. We have 1 chlorine, 1 chlorine, 1 hydrogen, 1 hydrogen, 1 iodine, 1 iodine, 1 potassium, 1 potassium. We're all set. Okay? So, we now are going to make ourselves a plan. We are given grams of Ki. Okay? From grams of Ki, we're going to go to moles of Ki. From moles of Ki, we're going to go to moles of KCl because we need to get to particles of KCl. From moles of KCl, we're going to go to particles or molecules, whatever you want to call it, of KCl. Notice that we don't have to do grams in there, because if you were paying attention earlier in the year, you would know that there is a direct relationship between moles and molecules. You don't have to go through grams. Moles to molecules, 6.02 times 10 to the 23rd. Remember that lovely number? Okay, so this is our plan. So here we go. We're going to write down 28.3 grams of potassium iodide. That goes on the top of our first fence post. 166.81 grams of potassium iodide goes on the bottom. 1 mole of potassium iodide goes on the top. You don't know where I got that number? Go back. Okay. Now we're going to go from moles of Ki to moles of KCl. 1-to-1 relationship. There's a 1 here. There's a 1 here. It's a 1-to-1 relationship. So do you even need this step? No. Do I always put it in? Yes, because otherwise you get lost as far as your units are concerned. So 1 mole Ki, 1 mole KCl. Okay? From moles of KCl, moles of Ki is going to cancel. We're left with moles of KCl. From moles of KCl, we're going to particles. So 1 mole KCl, 6.02 times 10 to the 23rd molecules, particles, pieces, whatever you want to say, of KCl. Moles of KCl cancel. You're left with molecules of KCl. We're going to do 28.3 divided by 166.81. We're going to skip this because it's 1 and 1. And we're going to multiply by 6.02 times 10 to the 23rd. So we're going to end up with 1.03 times 10 to the 23rd molecules, particles, pieces, whatever you want to say, of KCl. And that, my dears, is how that's done. Thank you.